All's it? All right, good morning. I'm really glad I have a bright light in my face so I can't see anyone, so I won't be nervous during this. This is good. All right, so got a lot of stuff to go through, so I'll go ahead and get started. As soon as I turn on my, there we go. So I'm Jimmy Balmert. I've been in the industry about 20 years, pretty passionate about clean code, test-driven development, so this is right in my wheelhouse and what I want to talk about today. If you're interested in slides, I'll put this up again at the end, but I've got all the code that I use for this entire presentation up there on GitHub along with the slides. They are in Keynote, so I can convert them to a PDF if anyone's actually interested in them. So I'll start off with a harsh truth. Something we have to kind of own here is you've been misled about TDD and how we sell it and how we try to get people to adopt it. And that's not even strong enough. It's we have misled you. Everyone who's tried to sell it to you. Well, maybe not everyone. I know I'm guilty. So let me show you an example. If I sold TDD to you or sold playing golf like we would try to sell adopting TDD, you can earn millions of dollars. You get to walk beautiful greens, travel the world. Oh wait, I think there's a little fine print there. Let me see if we can. Oh yeah, that's if you completely master the game. So sure, if you spend a lifetime and happen to be really good, those things are true. So when we come around and say, hey, let's learn TDD. It'll shorten your time to market, it'll improve your quality, makes developers more productive, will reduce bugs, will create solid code, will reduce rework, and darn it, fine print again. If you master the practice. So one of the things we fail to teach you when we swoop in and say, hey, we're going to give you a 1-week course on teaching TDD and you're going to be expected to do it from now on, is it takes time to master. It's a skill, right? We don't give you that breathing room usually. We have an even more fine print. So when we're teaching you TDD, we're not going to necessarily tell you what you're really aiming for. We'll just tell you clean code. Go write good code. The test will help you tell you when you don't have good code, and that's true. And you'll be able to tell when you're wrong because you'll feel the pain of writing really difficult tests. But we won't tell you how to fix that. We won't even be able to tell you why unless you understand the feedback from the test. But understanding and mastering TDD is actually twofold. If you're going to understand it, you have to understand that how to understand we've built the right objects and we've built the objects right. So on the left-hand side, we're talking about feedback from the tests, right? This is, I'm looking at the test, something's not feeling right about it, the design of the code isn't quite matching what I need. Versus on the right is, have I just done something that's poor design in the object-oriented space? Have I done something that would be anti-object oriented? You kind of have to have knowledge of both to succeed at TDD, at least in the Java examples I'm going to show you in an object-oriented language. So we come in and say, hey, here's the technique, red-green refactor, and I assume everyone's seen that or heard that at least once, right? Yeah. We swoop in and say, here's the mechanics of it. Write a failing test, write a passing test, now refactor it until it's clean. What? How do I know when to do that? Just do it. Right? We kind of abandon you at that point. So this is going to focus mainly on the feedback, but I will have a little bit to say on the design side of it. But that's a lot less established and a lot less accepted in terms of universalness. So feedback types, we want to evaluate our designs and our code and our tests in terms of abstraction, responsibilities, and usability. So what I'm looking for here in abstraction is, am I exposing internal state? Is it easy for you to get into this object and know what it's doing on the internal side of it. I want to create a wall where you can't see that. I also want to know, do I have a couple of fields that are being used frequently together? So maybe those should be grouped together and abstracted. Am I missing a domain concept entirely? Is there something in here that if I had something that more represented the problem domain would make my job easier? And overall, do I hide how my object operates? I want to expose, here's what you can do with it, and the how should be completely abstract. You shouldn't be able to know that. For responsibilities, I'm looking for things like, am I trying to get data from other objects to do my work? Am I trying to micromanage another object? Am I telling it to do a whole bunch of things? Am I responsible for more than one thing at a time? All of these things are sort of red flags that we should be taking action on. Now from usability, this is more of a heuristic on how easy is it to understand what this object is or what it does, just by the name or the methods. Can I easily test it? Designing for testability is one of those things, that's where your real gains come in. And can I express what I want to do with this object without having to worry about the underneath how? Now when I get over to the design side, it's all over the place. We can evaluate in terms of the solid principles, single responsibility, open, close, listgov, independent interfaces, and dependency inversion. I'm sure everyone's completely fluent with those and knows everything about them, right? Or we could try to do it in terms of just complexity. How many if blocks and loops and things do you have in your code? We can look at it in terms of cohesion. Do all your methods within an object tend to utilize all the fields within that object? Or coupling, do I make sure that I don't have tight coupling in that I'm not dependent on other objects to be there for me to do my job? Or at least the internal state of those objects. And of course the infamous high test coverage, which I think we can almost throw that one out. Yeah, it's a good thing to have, but it doesn't actually, it's not an indicator of a good design. So with all that, and the no established norm for what these things are, I have a few simple rules that we're going to adhere to for what we're doing today. First rule, an object may call only its direct neighbors. It's not allowed to go asking for neighbors to give it reference to other objects. Pretty simple, but actually very restrictive, and one of the ones that I get the most pushback on. Any object is not allowed to expose its dependencies. Meaning if you've been handed an object and you're supposed to do something with that, you're not supposed to hand it upstream for someone to do that. They can talk to you to do it. You're the gatekeeper, right? So to look at this visually, if I have this object hierarchy, and I look at just the top, that green object at the top, its entire world is just those orange objects. It knows nothing else below it, nor should it. Now if I pick any other point in this graph, the same should hold true for any of those objects. Now with that said, we're just going to make sure as we're going that these things are adhering to that design, but we are going to be focusing on the feedback side. So I've chosen tic-tac-toe as the problem that we're going to code against. A couple of reasons. Easy to describe. Has everyone at least played tic-tac-toe once, right? Rules haven't changed in the last 30 years, I hope. Pretty stable. But it's complex enough that I can demonstrate some TDD techniques and show you how I can go down a wrong path, and the feedback will tell me that. So before we dive into the code, real quick about the square nomenclature, just so we all agree on where everything's are on the grid when we're looking. We'll have left top, middle top, right top, middle, left middle, right middle, bottom, left bottom, bottom middle, right bottom, and of course center, because middle's kind of ridiculous. I All right. So we'll start out with an end-to-end scenario. And I recommend you have this kind of thing in your own code base. An end-to-end test. It's still going to be fast running and like a unit test, but it's going to be allowed to use real objects all the way up to the boundaries of your system. In our first scenario is X wins. And you just saw it played out. Whoever's playing O is probably drunk or just half asleep, and right? It's a valid scenario, not a likely one, but this shows us our easiest full game that we could do, right? X can win in 5 moves. And here's what our end-to-end test looks like. Notice I have tic-tac-toe, that's our main object, it's called game. We have a game display that I'm mocking, because that represents the boundary to my system. That's our feedback loop to whoever is the client of our library. And I have a game board. I'm guessing that I'm going to have to hold some sort of state, and I'm going to send that to the display for it to try to publish that information of, you've updated the board, here's what happened. Right? So I have a little before block to just put all the pieces together. And then on the right is my actual code representation of that first scenario. Granted, it's a little messy, and we will make it cleaner as we go, but this was first pass when I tried it out. And I have, well, this tic-tac-toe game should have the ability to place a square. So I'm going to say we can place X on a particular square. Then I'm going to verify that the display has shown the board. And that's going to happen after each move. So in this case, we've got O takes the middle square, X takes the middle square, O takes right top, X takes the middle top, O misses it and takes the left top, and then X takes the bottom square and wins. And we get a little message at the end that says X wins. I submit that this is a full scenario of expressing an actual use case, right? Because we're trying to match closer to reality of someone actually trying to use our code. And here's the bare bones implementation, just stubbing things out, no real code where I can get away with it. That test won't run yet, and that's okay. We were just writing an end-to-end test to become our guardrails as we start unit testing everything else below it. So we have tic-tac-toe, it takes in a display and a game board, and we have place X on and place, apparently X on twice, that should be O on, sorry about that. All right. We have, but just by necessity, created a square enum that holds all of the potential squares that can be taken. We have the interface for the game display, and we have our game board, right? And then we have a representation of the player X, another enum. This is all we were forced to build to get that first test to at least compile. It won't run. It probably won't run for a while until we've fully flushed out everything underneath it to make that scenario pass. But that is our immediate goal, is to write unit tests keeping in mind our only job is to get this first scenario to run. Then we can do another pass through and make another scenario run until we've covered all the likely scenarios that we're interested in. So from the very beginning here, I haven't even written any real code. I can already tell that there's a problem with what I've done. From an abstraction point of view, I'm exposing internal state because I'm telling the client, you have to know which player is moving next. Probably shouldn't do that. But I don't have any code or any unit test to tell me what's wrong yet. So I'm just going to keep that in the back of my mind, and we're going to move forward, right? And from a usability standpoint, again, we're allowing the client to do something wrong. Probably should prevent that. So now we're going to go back to that exact same tic-tac-toe class, but we're going to address it from a unit testing point of view. So we had our end-to-end test, and our rules there were we're only going to mock the very last step in the chain that talks to outside systems. Now we're going to be able to mock anything we want. So now we have a mock version of the game board. And our test says we want to store moves on a board. So if I were to place X on a square, I should be able to prove that we call board take square. Here's the player, and here's where the actual square you're taking. This is, of course, a very naive implementation of it, but we're just starting out with our unit testing of this. On the right, we've actually implemented that. If I call place X on a square, it's going to take that square with player X and the square you sent in. And so here's my object graph now. If it's in blue, it's got an implementation or a partial implementation. If it's green, it's been stubbed out or it's just an interface. And if you see red in the near future, it's just something that we're about to introduce. So with that, we can jump into our second test, because I didn't get any useful feedback out of that. Nothing particularly wrong, nothing jumping out at me. But let's start introducing a game evaluator, because it's not enough to just store the moves. I actually have to determine who wins the game. So my first thought is, well, that should be a separate responsibility. Let me create an object that will handle doing that for me. I don't know the specifics of it. It's just a domain concept to me, a game evaluator. So I'll come in, I'll add a new mock variable for the game evaluator, and I'll add a new test. The original one's still there, just ran out of room. So we say we want to evaluate the game state after a move. So if you, again, come back and say place X on a square with a particular square, we should be able to get a message going out to the evaluator to saying, evaluate the state of this board. And if I come over to the right, you notice I added the dependency on the game evaluator, and I evaluate a state with a board in it. Kind of dry, but we're getting there. And this forces me to create a stub for the game evaluator, and now I've got this. I know, moving through. All right, so now I'm starting to think about, I was hard coding the player in there, so I'm already doing things wrong. And I already noted before I even started that I'm letting the client figure out who the player is. So I'm going to try to address that here by introducing a player tracker. So first thing is I need to fix my interface. And instead of place X on and place O on, I now have just place. And it will be implied, well, it'll be tracked internally on who's taking the next move. And we'll figure out toggling and all that kind of functionality. So for that to work, I need to have a dependency on my player tracker at the tic-tac-toe level, at the top level game. And I want to say signal start of a new turn, that when I say place square, the player tracker is told, hey, the next turn is occurring, get me the next player, broadcast that out. And you can see the implementation on the right. It's just adding another call, and it just says player, it's next turn. Haven't gotten into any of the details of how it actually works. This is just me wiring it in. So if I come back up to the end-to-end test, to make this compile now, I need to do slight repairs. And I'm not going to come back to it every time, but you should assume that as I'm changing the design below, the end-to-end scenario needs to be updated slightly to reflect the new reality of how the objects fit together. So this will be a continuous, up-to-date map of how all your objects should be wired. So we have a simple update to say, place game.place, and if you look on the right, we're just taking out the place X on, and we're assuming that the state of the game knows internally, here's what we do. It's player X, that's player O, that's player X, that's player O. So we have an empty player tracker, but we've wired it in. But it's useless right now. And we have sort of a broken system. So let's make this real. All right. I should say, we'll step back to that in a moment. For now, we're going to look at the game display real quickly. We just want to show that we're actually leveraging it somewhere in the unit test. So we're going to say when we displaying current board, we're going to say when we place something, we expect to display something. And if you look on the right, we're adding that into our call. Pretty simple. But now I'm starting to notice something. If I go back here real quickly, the game display object is being told, show the board. It's going to be very hard for it to do that without knowing the internal state of the board. The game evaluator is being asked to evaluate the state of the board. It's going to be very hard for it to do that without understanding the internal state of the board. Both of those are against my design rules. I can see it coming, and we're going to have to fix that. So we're going to try giving the board a little bit more responsibility and sort of change the relationships here. So we're going to say, when on the tic-tac-toe test, that when we evaluate a game state after a move, that we just say verify board evaluates game state, and is handed the game evaluator. Before, I had the evaluator taking in the board. So I'm inverting that relationship, and this happens frequently when we're trying to figure out the right relationships and how these things should be put together to obey the proper design rules. And we're going to say displays the current board. And again, we're going to say board display, and here's the display you can use to do that. So what does that buy us, inverting those two? What it does is says the object that holds the data is now in charge of sharing how it shares that information. It can push that information out to the target rather than something reaching in and pulling it out. And the difference to that is subtle, but it's very significant, because it means you have full control of what you're sending. So you can opt to send a little bit of it, you can opt to send all of it, you can opt to create a different representation and push it out the door. Whereas if something's just pulling it out, it can just go in and it's just going to rip out your internal state and operate on it. So if you notice on the right, we now have board take square, board evaluate state, and board display. Three things that are going to happen the same way every time. And this is what our game board looks like. It's just been stubbed out. And our game evaluator has lost any of its methods, which is fine. We'll come back to it. But now we're running into a slightly different problem. The responsibilities. I have the game micromanaging a board. It's telling it, do this, do this, do this, do this. It's taking on too much responsibility. We'll address this, but first we're going to get back to the player tracker and make it actually functional, and then we can come back and actually clean up the board. So, our player tracker test. First thing we want to have is this concept of current player aware. It's just an interface that we're going to talk to. Any object is welcome to implement this interface and register itself with the player tracker. And the contract there is anytime next turn is called, all of those current player aware objects will be told, here's the next player. No need to go asking for it, it'll just automatically be pushed and always kept in sync. So we have our next turn and we have our register abilities, right? And I have basic definition of the interface here. You should be told, here's your current player, and it'll send a player object. It'll just toggle between X and O. So how do we make that toggling happen? Well, I have to test it and prove that that's going to do what it needs to do. This looks a little tricky, but all this is saying that I want these events at the bottom in order verify. I want these things to happen in this order. It should first say X, then O, then X, then O, and I should be able to repeat that forever. And the easiest way to do this is really just have a toggle and just ask, if the current player is X, return O, otherwise return X. This forces me to finally implement the other player. We now have two players in the game, finally. So now I need to say, it's not enough to have just one current player aware object. I may have multiple. anything that's registered to me, I should send this signal to. And so I'll say I'm going to notify my listeners, and now I'm holding a list of these. And for each one on the list, I'm going to go ahead and call current player. So now I have, instead of talking to one object, I'll just loop through all of them and handle that. So from a responsibility standpoint here, I'm noticing one small problem. My player tracker is actually doing two things. And I'll come right out and say it right up front, this is overkill. But for an enterprise system, this is the difference between a real quick modification later on and something that can be really painful and tedious later on because people keep tacking on functionality to an object. I have never regretted breaking down an object into smaller pieces. So I'll take my tests, take what I just did with the player tracker, throw it away. Empty test, empty player tracker, and we'll start over real quickly. So now I'm going to assume I have, since I thought I had two responsibilities, I'm going to assume I have two dependencies that take care of those responsibilities for me. So the player trackers are now going to own a player toggle and a player broadcaster, because it was responsible for toggling and broadcasting all by itself. Right? So the first test is gets next player from the toggle. So whenever you call next turn, verify that player toggle call is called with next player and it gets it back. And then I'm going to say it sends the next player to the broadcaster, right? So when I get that next player, I'm going to call off to the broadcaster and say, broadcast current player. Pretty simple. This object now has one responsibility, and that is coordinating, collaborating with two other objects to get the thing done. This is one of the easiest ways to resolve issues with too many responsibilities, is just give them to other objects and make your top object that was doing all the work a collaborator. So the implementation now, pretty simple. I call player toggle next player and get that player, and then I hand it right off to the broadcaster. Again, this is complete overkill for our actual problem, but I would submit to you that this is easier to read than what we had previously, and a little easier to understand and reason what it's doing. So I now have a player toggle and a player broadcaster I need to implement. And we'll jump into those real quickly. They're pretty trivial. They both own one responsibility, so the toggle just needs to have the test that says every other time return me X or O. And again, we are just going to verify those at the end, or to call these assertions to say, I'm getting player X, I'm getting player O, I'm getting player X. And it's pretty simple. I'm using that same ternary block to determine if it's already player X, return me O, if it otherwise, return player X. And that's what I hand back. Then we get to the broadcaster. And we're going to say, this handles talking to all the listeners that are interested in knowing when a new player is up. And all you have to do is say broadcaster register your listeners, and then broadcast the current player, and we'll verify that all the listeners that were registered will be given those values. And so this owns that little for loop, and that's all it does. So this is our object hierarchy. I'm happy with the design as it is now simply because I'm obeying my two rules. I don't hand up my dependencies to anyone else, and I keep those hidden. And I only talk to one object below me. All right, so we'll get back to the game board now. We were noticing a little bit of design issues with it. And the problem shows up almost immediately when I try to unit test it. So if I say, I want to track squares taken by player, right? What assertions should I be making here? What verifications should I make? I don't know what this thing holds right now. I don't really have a clue on how it was really supposed to do this. I do know that I have these three methods that are going to be called in order every time. And we noted that the tic-tac-toe object was micromanaging and calling these three in sequence every time. But I can say I take the square and it eventually should go to the game evaluator, but that doesn't happen within take square. Nor can I say it's going to display right there within that same method. So these are all hints that this object doesn't have its responsibilities laid out correctly and that something else is sort of taking those away. So this is our micromanagement problem. Tic-tac-toe is just doing too much of the job. So that means we need to go back up to the tic-tac-toe object and redrive out how it interacts with the game board and simplify it. And here's what we're going to do. We already have the method to say take square. We're just going to stop at that point and assume that the evaluation and the display stuff happens downstream inside the board itself. So now we're not going to call all those three things in sequence. And so our test reflects that now. Store moves on board. We just have the take square. The other tests have disappeared. And our implementation has simplified too. I don't have a reference to the evaluator. I don't have a reference to the game display anymore. I just say, it's the next turn has started, and here, take this square. And that's all tic-tac-toe cares about. I'm done. You do the rest. I'm not micromanaging you anymore. So now I've left game display and game evaluator as orphans in my object hierarchy. I'll get them back, but this is how we start. We sort of have to break those dependencies and then reassemble them or reassign them and push them down to the correct level. So let's go back and try to retest the game board. When I tried before, it had three methods, and I couldn't really get started because I really couldn't test any side effects or anything coming out of it based on what was happening with the initial call. So it was becoming difficult to test. So now I'm going to say, first things first, it is current player aware, meaning it's going to understand when the player tracker has said next turn. Pretty simple implementation for it. Now we're going to get into a little more complexity. And we're going to say, sends moves for player X to the evaluator after player X takes a square. That is long-winded, I'm sorry. But we need to express what's actually happening in this test. So we need to make sure the current player is player X. And that we are saying take the left bottom square. And we're going to say, game evaluator, evaluate with this captor, which is really just some really interesting capabilities for testing from the Malkito framework. But all this says is, get me a reference to whatever is being called inside this evaluate method and let me hold on to it so that I can make assertions against it later. It's kind of convoluted. But I should expect a set of squares to be sent out to the evaluator. So I'm finally starting to define how we evaluate things, or at least the contract I want. And then I'm going to say, not only do I get that set of squares, but I can evaluate what's inside it. So I can prove, if I made a move for player X, you're going to evaluate the moves that came from player X. So we're going to say it contains exactly that left bottom square that I told the board to take. And here's where I start introducing a little more complexity. So I'm storing two sets of squares. One for the O moves, one for the X moves. I just want to keep those separated because it's at any point in time, I only need to evaluate one or the other. Last I checked, X can't win when O places a square, right? I only have to check O's moves when he moves. So I'm creating this structure of a map of player to set of squares. That's a little ugly, and we'll try to deal with that. But when we start up when we create the game board, we're going to register these two sets of squares. And we're going to set up the evaluator, and then we're going to say, when we take a square, get the appropriate set of squares, add this new square to it, because someone's making a new move, and then evaluate that set. Send it to the evaluator to figure out, did someone win? So I've reattached the game evaluator to my object hierarchy. I still have game display dangling in the wind. Right? All right, so we're going to start evaluating player O moves right after X. So I'm trying to make a distinction here. So that original test is still up there. But I'm trying to prove that if player O makes a move, it's stored in a different location than player X. And that is significant to the design. So in this case, I'm allowing it to have player X take left bottom and player O take square center, right? Take the center square. And then I'm going to verify that the only thing that makes it to the evaluator on the second call is the squares that are destined for player O. That is, we're separating those out, and I put them into a different set of squares, so when the second move is made by player O, we're only going to evaluate his moves. And that's what that assertion at the very bottom says. So we're trying to prove that that's what's going to happen. And how do we make that happen? Well, the only thing we really need to change is not hard code, which is the current player, because we're going to be current player aware and or have that sent to us. So that player tracker is going to broadcast that information, and we'll know who the player is, and therefore we'll know which set of squares to dump the move into. And that way we're going to keep track of those separately without really trying too hard. And so now I have this contract for the game evaluator. I should evaluate a set of squares which represents a snapshot of the state of the system for that particular player. So I said that map of player to set of squares was a little wonky, little too low level for me. I feel like I'm missing an abstraction to handle the player moves. So I'm going to try to replacing that entire structure with an object. So I create my test to say add squares to game moves. And when I take a square, it's now going to verify that I'm adding it, that the moves is being called and saying add this square. And sort of throwing out the concept of here's a map that holds those things, or at least putting that somewhere downstream so I don't have to deal with it at this level. And I try to tell moves to evaluate game state with the game evaluator. So when I take that square, I should be able to just say, hey, the thing that represents my moves, evaluate the game's, evaluate the state, and here's the game evaluator. Now my problem here is I'm immediately falling back into the trap of micromanaging an object, which tells me my design is off. So as soon as I've gotten to that second test, I'm stopping, and I'm going to back up and reevaluate some of this. So this is what my object hierarchy looks like right here. And the feedback I have for it is, in retrospect, game board is actually going to adequately control and hold that state. What I was really missing is something to represent the set of squares. I can still have a map of player to squares. It's just the fact that I was making that have a relationship with a set of squares that I think was actually causing this to be a little tricky. So we're going to try this one more time. We're going to go back to where we were. And this time I'm going to have the set of instead of sets of squares, I'm going to have a squares object that represents that. And I'm going to hand those in to the game board when we build it. And now when we take square, we'll just say player to squares, which is our map of player to just squares. Get the current from the current player, add this one. So we're still going to say two different squares objects, pick the right one and add this square to it. So now game board has a dependency on a couple of these square objects. And that feels much better. I think we're not having the same pain, we're not micromanaging, and I've cleaned it up a little bit, made it a little more palatable. So we're going to drop down and start test driving the squares. And we're going to say, we're going to evaluate the game state after a square is added. So the evaluator doesn't belong at the game board level. It actually belongs attached to these squares, because it's going to have the information to be able to send forward to tell the evaluator, here's exactly what you should be evaluating. The game board isn't actually going to track that very well for us. It's dumping off that state to the squares and delegating that responsibility. So we evaluate the game state after a square is added. So we're just going to add squares and we're going to verify that we're evaluating, and that we're going to have the exact contents of the set that is actually sent through from that squares object. So underneath the covers, we still have that set of squares, but the squares object is in control of sending it out and making sure it goes to the right place and only exposes it when necessary. And so the implementation becomes pretty simple. It'll own a set of squares, it'll have a game evaluator. I don't have to send it in anymore. We're going to assume it has that as a dependency. And when you create it, you tell it, here's the game evaluator you're going to use. And both squares objects are going to be sent the same evaluator. And when you add a square, we'll track it in the correct set, and then immediately send that set down to the evaluator to see, did someone win? So we're making progress. Now we have a slightly different contract for the game evaluator, but it's more or less the same. But now we've attached the game evaluator under the squares. So it's gone from the tic-tac-toe object owning the evaluator to pushing it 2 levels down. And all of this is just by following the feedback and trying to understand the object relationships. So now we're trying to circle back and get to the game display. And one of the things I'm noticing, I'm not really telling it how to display anything. In fact, my original concept when I was writing this was to try to make it a command line console app. Well, that sort of influenced my decisions on the names, even though I was only writing a library that could be used in any kind of way. This could be used for a web app. This could be turned into REST services. This could be whatever you want. Yeah, that is kind of ridiculous, but it could be done. So what we're really looking for is events, not really display. So we're going to try to rename that and come up with something to better express what we're doing. So we're going to start at the game board, and we're going to say, sends a move event when square is taken. So I'm going to tell it what my current player is. I'm going to take the square, and then I have this new method on the events object, which was the display, that says, here's a move I just took. I'm not sending the entire board. Don't really need to do that. I really just want to send a message back to confirm back to the client, you told me to take this square. Player X has taken that square. That's all I'm telling you. And then the implementation, pretty simple. Takes the square, or it calls the move. And here's our game events interface now. Still have X win, and now have this move with a player and a center or a square. So now if I backtrack to my end-to-end test, remember I'm supposed to be repairing this as I go along, I now have a much more expressive way of describing my test. So I'm doing all the same things. If you look down at the bottom at all of that test, that X wins a game, I just rearranged and took the assertions and moved them to the bottom. So the top part expresses, I think pretty succinctly, here's what's happening in the game. The center square is taken, then right top, then middle top, then left top, then middle bottom, and the game's over, right? And now I can say, these are the events that should have happened from that in the exact order, and it'll take into account which player took them and which player won. So now I'm being able to say, player X took center, player O took the right top, so on, and go all the way down to X wins. So cleaning up our design actually made it really much easier to express our code, which tells me we're succeeding on our usability front for evaluating our designs. This is becoming easier and easier to use and express the what without worrying about how it happens in the back end. So here's our current object hierarchy. I've got this game events interface, and I've got the game evaluator. So now it's time to start driving out the game evaluator itself. Sends X wins if any solution matches. So keep in mind, after every move, we send the set of squares for that player to this evaluator, and its job is to just figure out, is there any solution that matches this? If so, that player is won, and we're done with the game. So we're adding in this concept of a solution object, and we'll drive out what's in it later. But we should be able to say, if you send me a set of the squares, I should be able to evaluate that or ask each solution if it matches that set of squares. Does a subset of that square match what's in the solution? If so, we return true, and that means, hey, you've won. If not, if all of the solutions don't match, then we're done, and we just say you haven't won yet. Now, it's feasible for us to do this simply because there's only 8 valid solutions in tic-tac-toe. 3 across, 3 vertical, and 2 diagonals. If this had a much larger grid, we'd probably have to do something much more dynamic here and figure out things on the fly. But I'm taking advantage of a very stable set of specifications. So our implementation is pretty simple. It says loop over all the solutions and track if any of them return true, and we'll say that is has winner. And if after we're done, we have a winner, we're going to send the X wins event. Pretty straightforward. And likewise, we're going to put a test scenario for the negative case to say, if nothing matches, we don't do anything. We don't send any event. So all I'm putting in is a verification that no events were sent, that nothing was called on it, which means there's nothing changing in the code. There's nothing to implement for that. It's just a proof to ourselves that we implemented it correctly there. So now I come to this solution object that I've just generated. I've got 8 of those. So I've got sets of those solutions again. So I kind of want to repeat the pattern I did with the square and say a square should have squares that encapsulates it. Solution should have solutions that encapsulates it. And the game board is responsible for generating events and determining if a solution matches player moves. So we'll see about that. So we're going to change the set of solutions to just solutions in our implementation real quickly. So instead of sending me a set of solutions, we're going to be sent in a solutions object. And we are just going to say matches one time on it instead of looping over it. We'll let it do the iteration internally and figure that out for us correctly. And so in the first case, we want to say, yeah, it returns true. Well, in that case, we send the X wins event. If it returns false, we don't send any event. Pretty simple and straightforward. And so our code just becomes this. Before we had a loop and we had to figure out that flag and set it correctly. Now we can just directly say, if the solution matches these squares, we have a winner, let's send that event. Minor simplification, but these minor simplifications add up. And here's our solutions object. So I've sort of orphaned the solutions, or the solution objects, when I introduce the solutions. Now I need to put that back in and actually implement the solutions. So it returns true if any solution matches, so I just need to have one solution object that returns true. And if that's the case, when I iterate over it, my result should be true. If, however, everything returns false, I should just say it doesn't match. And this is my solutions implementation. Pretty simple. You send me a set of squares, I'll loop over all my solution objects and ask them if they match. If any one of them says it does, I'll immediately say yes, true. Otherwise, it'll return false. So I've updated my object hierarchy again and reattached the solution underneath the solution objects under the solutions. And then I'm coming to the end of the hierarchy. I actually have to implement the tricky part. How do I determine if someone has won a game of tic-tac-toe? I've deferred this and deferred this and deferred this and deferred this. And I'm sure it's maddening to watch. So we're working with sets. Thankfully, the sets objects that are provided in Java give us a few convenience methods that will do the hard work for us. So really all I have to do is say, when I call this matches, is figure out if a subset of those elements within the square set that's sent in matches the three square values that I was given that defines my particular solution. In this case, I'm hard coding in middle bottom, center, and middle top, which just happens to be the solution that X wins in our first example. And so if I create a set of squares that has right, middle, center, left, middle, top, that doesn't have all of three of those elements from my actual solution, we expect false to come back. It doesn't match it. However, if I have middle, bottom, center, left, middle, and middle, top, that does match because I have middle, bottom, center, and middle, top within it. It's a subset of it. We get true. So here's our really difficult implementation that I kept running away from and deferred. Well, I create a set from the squares that were handed to me when I build my solution. And then I ask, does this set of squares you've handed me contain all of my elements? And I return that. And there you go, I've evaluated my solution. So I've got everything implemented except for the game events, and I really don't need to do that because that's meant to be for our client to implement that interface and accept the incoming events and respond correctly. So you could build, like I said, a console-based app or a CLI kind of thing that when you receive the feedback that you have made a move, you can just go on to the next player and let it move. It'll tell you which player took the last square so you can prompt, for the next player or the next move from O. And then submit that information by calling take square, and it'll go do this. And it'll eventually send you back this information saying, this player has won. And we've completely done our first scenario. Now, I've had to go back and do a little surgery on it and fix up how we wire everything up. But again, this is a live roadmap that shows us the exact relationship of all the objects if we want to look through it. So I have this solutions equals build valid solutions. Didn't have enough room on the screen to show it all at once. But I hard-coded all the solutions. Again, I'm taking advantage of stable specifications. I'm cheating, sorry. But it's okay in this case. The rules to tic-tac-toe haven't changed. Now, if I were to expand this and suddenly say a new requirement, we need to handle an arbitrary grid up to 10 by 10. This solution wouldn't work. I would have to go back and rework how my solution objects work. But I'm willing to wager with you that it would be contained to just that area, just the part where I cheated. That I would just have to find a new way of evaluating if your particular set of squares matches a solution. Everything else in it would just work the way it does. And that's not really by accident. That's by going out of my way to create the tiniest objects I could by listening to the feedback from my tests. And that's sort of the secret sauce that we kind of don't really share with people when we're trying to teach. We're much more worried about the mechanics. Here's red, get a failing test. Here's green, oh boy, I made it pass. And here's this nebulous refactor phase that you'll forget about and just get into red, green, red, green, red, green, red, green, and move really fast. And suddenly you've got this huge blob of code. If after each test we're evaluating and figuring out do we have good just pure object design, and does that object design meet our needs, we tend to get better feedback and better decisions on how do we adjust this for my needs. Now, at no point did I start thinking about gold plating my code. Everything I put in here contributed directly to the solution, right? There's nothing extra in here. I didn't put anything for error conditions, didn't put anything for stopping you from continuing to play the game when the game is over, although I do have some scenarios I can show you for that. There's no gold plating to it. I'm no guesswork. I literally built it to exactly what I needed it to do, but I've got a pretty clean design that it should make it really simple to modify it and add in some of those requirements, right? And here's what our first scenario looks like. So I have other scenarios that I'm not going to step through all of these because this one is actually trivial. I hard-coded a player X in one spot and had to go through and change that to just say current player, and this started working. Game ends in a draw. Really all you have to do is see if one set of solutions gets to a size of 5, or I'm sorry, one set of moves gets to a size of 5 without winning, and you're in a draw. But what about trying to make an illegal move? One of the things when I'm teaching TDD, everyone wants to jump into the negative use cases. Well, I have to validate the inputs. I have to make sure that this is happening before this is happening. I can't allow this. And it gets really hard to say, let's just focus on happy path for the beginning. But we just did that. So let's indulge ourselves and look at what we can do to try to prevent an illegal move from happening. So I want to be able to say, if I place center twice in a row, that the first one should be allowed. I'll get the move event. And after that, I should get an invalid move. And ever after that, I should get invalid move. And I want to add that to my interface. So if you've read any of the books by Michael Feathers, he talks about working with legacy code. He talks about the concept of a seam. And we're lucky here in that we're not actually in legacy code because this is all fully tested. But we still want to have this concept of a seam. And what I'm talking about as a seam is I want to find a point in my object hierarchy where I could inject something in between it and not actually change any of my code, but still implement this. So with the exception of extracting an interface, I'm going to leave my entire code base alone and just add some things around the edges, and I'm going to implement this. And this is kind of the mode we should be in when we're trying to create our enhancements for our code. If we're trying to obey the open-close principle in solid, right? Should be open for enhance or for extension, but closed to modification. So I'm going to try to make it so I don't modify any of my existing code. The only thing I really need to do is say, well, I have my game board, and this is my entry point to understanding if I'm making an illegal move or not. And I need to turn it into an interface. And I'm going to rename the original implementation to player game board. So I've done a huge refactoring here and just said, I have an interface on top of this now. And tic-tac-toe depends on that interface, not on the implementation of the actual player game board. By doing this, I now have the ability to write the functionality to prevent illegal moves without touching any of the other things that are in blue. I will not modify any of that code. So I'm going to insert a new object that also matches that game board interface, and it's going to be before the player game board. I'm going to say, if it's a valid move, let it through. So I'm going to have game board validation as my object, and it's going to have this idea of the delegate, which is the original one, right? And we're going to have the same thing with the events, and we're going to say take square, and we're going to verify that that square is valid, so we're going to let it through. Because we're saying the move validator is going to tell you when you take the square that it's valid. And so it's a pretty simple implementation. It just says, if my move validator says you're allowed to take this move, I'll go ahead and let it through. Otherwise, I'm going to have to send through a message when the move is invalid. And I'm going to have to prevent it from being taken. So in this case, I'm going to say, when the move validator is called for is valid, it's going to return false. Am I doing? Okay. And we're going to take square. I'm at over. Okay. I'll tie this up really fast. So we're just going to say there's 0 interactions on the delegate, and that we are going to get an invalid move message. So we implement that really quickly, just saying if it's not valid, we say invalid move, and we're going to say return false on here. Just a real quick implementation of it. And so this just needs to have, the move validator just basically needs to be told, if the move's already been taken, don't allow it, and that we can't have a null move coming in. The real simple way to do this is just to say, here's a set of all available moves, and I'm going to remove it each time you take a move. And if you try to remove it a second time, the built-in functionality from sets will actually return false, and that'll trip the thing to say it's not valid. So I have to rewire my end-to-end test a slight bit to take into account the new objects. And here's my final object hierarchy. Didn't change a thing in anything that was blue down below, but now I can confidently say you can't take an illegal move. You can't take a second square twice, or take a square twice in a row. All right. So when we're looking at feedback, we're looking in terms of abstraction, responsibility, and usability. We want to hide data. We want to look for missing domain concepts. With responsibilities, we want to make sure the object that owns the data operates on it, and objects should have one responsibility. And from usability, we want to make sure that we can easily express what we want to do, and it should be easy to test. From a design perspective, make sure that you have your standards for the clean code, and you constantly keep it clean. So thank you, everyone. I appreciate your time. If you're looking for the slides, they're up here, and thank you very much.